Hello and welcome to another episode of Christian Relearns Math, where today I relearned the intuition for the distributive property. Now, say we have a multiplication like this. How would you do this? Well, I mean, if we're trying to do it in our heads, we could do 37 plus 37, which is 74, and then plus another 37, which is what is that, 111, then plus another, that's getting kind of a lot. So perhaps in school you might have learned this method for performing multiplication, and we set it up like that, and then we do, what is this, 6 times 7, which is 42, carry the 4, 6 times 3 is 18, and then plus 4 gives us 222. Look, teacher, I got the right answer. Done. Or, well, maybe not, because yes, I mean, we did get the correct answer. We performed the multiplication correctly, but we sort of skipped the intuition for why that actually worked, or at least in this method. So, I mean, yeah, we did get the correct answer here, but using this method, this approach here, it skips a lot of the intuition for why this actually works. And then concentrating on the mechanics of performing something like this, which is what I did, instead of really concentrating on the intuition of why this actually works and what's actually happening here, that has caused me no end of grief, no short amount of grief in my life. And so that's what we're gonna do here. We're gonna focus on the intuition for why this is true. Why does this mechanics work for a multiplication like this? So the first thing we might do is remember that what do these digits and this dot in the middle mean? What is that saying? Well, if we recall, multiplication is literally repeated addition. So what this notation is saying is, let's say that we have a group of 37 of something, and then we want to add 6 of those groups together. That's literally what this multiplication is saying. So we could rewrite that expression as 37 plus 37 plus 37, and we would have 6 of these 37s. We can literally rewrite this as 6, 4, 5, 6 groups of 37 added together. Okay. So yeah, sure, but how does that help us? Well, let's take this one step further. We can also remember that this notation, these digits, this 3 and this 7, what is that saying? That's saying that we have a group of 30 plus a group of 7. That's a way to write 37. So we could also write the same thing as 6 groups of 30 plus 7. So here we have 1, 2, 3, 4, 5, 6 groups of 30 plus 7. And we're remembering that multiplication is literally repeated addition. Okay, so we can rewrite our repeated addition as multiplication. 6 groups of 30 plus 7. So yeah, I mean, we get it. We get that this is the same thing as that. Those are two equivalent expressions, two different notations for saying the same thing. But how does that help us? Well, something else we can do is we can think of this visually. Okay, well, how would we think of it visually? So let's say we have a rectangle here, and let's say that this rectangle has sides that are these lengths, 37 and 6. So this one's 6, and this one is 37. So that means that the area of our rectangle, because remember, area of a rectangle is length times width, so the area of our rectangle is 37 times 6, or whatever this comes out to. But we also remember that we can represent 37 in a different way. We can represent 37 as 30 plus 7. And if we think about that visually, what that would look like is 30 and 7. So what have we done here? Well, all we've done is we've split 37 into 30 and then 7. And then if we look at the smaller rectangles that we've formed here, well, what's the area of this first one? Well, we have a length of 30 and we have a side length of 6. So that's 6 times 30, which is 180. And then what's the area of this other one? Well, it has a side length of 7, and then what's the side length here? Well, we started with a rectangle here, and then we made smaller rectangles from it, which means that all of these angles are right angles, which means that this and this, those two lines are the same length, which means that this line here is also 6. So that's 6 times 7, 42. So what's the total of these? Well, we have 180 plus 42, which equals, when we perform that addition, 222, which is the same thing we get when we perform that mechanical multiplication. So yeah, that's pretty cool, but this mechanical one was a lot shorter. We didn't have to think about any of this rewriting term stuff or like drawing out rectangles and things. The mechanical way is a lot shorter. So why would we ever want to do this? It seems like way more work than the multiplication that we learn in school. Well, imagine what would happen if we're not dealing with numbers that we know the quantities of. What if we're dealing with variables? For example, let's replace all of these with variables. Let's say we have A plus B, and then we have C groups of that. So C times A plus B. Okay, so how would we do our mechanical multiplication for that? Well, we could try, let's try A plus B and then multiplied by C, and then how do we C times B, but it's plus A? It gets a lot tougher when you try to do the mechanical multiplication with variables here. Okay, let's try it though with that rectangle approach. All right, so we'll draw our rectangle here. Again, we're going to pretend these are straight lines. We'll say this side is C, and then this side is A plus B. Okay, well, if this whole side is A plus B, that means that somewhere along that rectangle, there's a length of A, and then the other portion is the length of B. Okay, well then what are the areas of these? Well, the area of this smaller rectangle, area of a rectangle hasn't changed. That's still what? That's C times A. Okay, so that's C times A. And then what's this one? Well, the same thing applies for the length of this. We're saying these are all straight lines, and more specifically, it's a rectangle, so these are 90-degree angles, which means this one that we make another rectangle from is also a 90-degree angle. And more specifically, it's parallel to this side here. So it is, with all of that said, it is the same length. So this is C times B. So what's the total of these? Well, we have C times A, and then our other rectangle is C times B. And that is the same thing as this first one that we started with. A plus B, that quantity, times C. And if you notice here, what's happening is that when we're multiplying this quantity by a sum, and our sum in this case is A plus B, and remember, we're visualizing that as the length of a side, where the total length is made up of several smaller lengths. In this case, we have a length of A and a length of B. So if you notice here, what happened is that we took the C and we multiplied it by the A, that part, the C, and we multiplied it by the A, and then we took the C and we multiplied it by the B, that part, which is this smaller rectangle. And it's the sum of those. And what's really cool about this is this same thing holds for however many sums that we have in this. We're pretending those are straight lines. So let's call these, I don't know, how about we have A, B, C, so how about D, E, F, G? Well, what's this? The same thing, for the same reason that side is equal in length to that side, the same thing holds for all of these other sides. These all have length c. So then what's the sum of this whole shape? Well, it's the sum of each of these smaller rectangles. This first one here is what? Is A times C. And then what's the second one? This is B times C. And then the third one, D times C. And so on for each of these smaller rectangles. F times C plus G times C. Now notice here that what do each of these terms have in common? They each have C as part of them. And that really is the crux. That's the central piece of why this whole thing works. Every term, when we expand out a distribution like this, will have a common piece. And so that then is equal to C times A plus B plus D plus E plus F plus G. And these are two different ways of expressing the total area of this rectangle. And again, the total area here hasn't actually changed. We're simply expressing it in two different ways. We have this quantity C times multiplied by this whole quantity in here. A plus B plus D plus E plus F plus G plus all of those. We're saying we have C groups of whatever this quantity is. Remember that multiplication is repeated addition. So we're saying whatever this thing is, add that together that many times, C many times. And that's literally what we're expressing here visually in this rectangle. And we can also express that same thing by saying, well, we have a number of things, and then add that together C times, C many times. That gives us this rectangle here. And then again, B number of things, C many times. We have C groups of B, B times C. And then the same thing for D and E and F and G. Two different ways of expressing the same algebraic information. Now, typically you'll see the distributive property written like this. It'll say A plus B times C equals A times C plus B times C. But again, that's saying the same thing that we discovered down here. And again, it doesn't matter how many terms are in this sum. So any sum multiplied by some quantity is equal to that quantity multiplied by every term in the sum, and you add all those together. So that's the distributive property. It comes up literally all of the time. It is so incredibly useful. I hope you found that explanation helpful. I know thinking about it certainly helped me. Make sure to like, comment, subscribe, share it with a friend or family member who needs to see it, all that good stuff. Have a wonderful day, and I will see you next time. Bye!